Palo Alto studio connecting Silicon Valley and Wall Street.
I'm John Furrier, co-host here with Dave Alave, my co-host.
Welcome back to the CUBE studio. I'm Gemma Allen here live at the New York Stock Exchange. This is AI Factories, one of our programs with NYSE Wired. And joining me now is Waleed Atallah, co-founder and CEO of Makora. Welcome, Waleed.
Thank you for having me, Gemma.
So first of all, I'm going to start with something I read because this made me laugh. You wrote a blog called GPU Go Brr, right? Meaning like a cranking of a physical, something that's kind of running out of steam a little bit, which really defines what you hope to achieve with Makora.
That's right.
Start there, break that down.
Well, GPU Go Brr, as the people who used to have their GPU sitting on their desktop know, once you get it really cranking, the fans start really turning on. You hear that. You hear the brr, and you know how well you're utilizing your GPU by how loud that fan is.
So Makora really is all about helping. It's not about there not being enough chips. It's about maximizing the GPUs that you have, right? That is really the premise of this business.
Look, I mean, I think the whole industry is compute starved at this point. From my conversations with other clouds, with other providers, the backlog on getting new GPUs in the door is something like 12 months, especially for some of the latest chips.
Okay.
So you want to make the most of what you have now, and we also want to enable people to make the most of other types of chips beyond just GPUs. So we're talking Google TPU, Amazon Trainium, AMD, all these new chip startups too, Tenstorrent, Cerebras, you name it.
So you're completely GPU agnostic. You're like Switzerland.
That's right.
I love it. So in terms of what it takes, though, to truly, make the most of the physical, metal you have, what go kind of deep on this from a tech perspective? Like, what exactly is involved in this?
Yeah. So the most important piece is, a chunk of software called the kernel, the GPU kernel, or the TPU kernel. Essentially, it's how you map an algorithm, like a model like ChatGPT or Claude Code or anything, how you map that algorithm to the hardware itself.
Okay.
When I hit enter on ChatGPT and I ask it a question, it runs something like 1 trillion math operations before it returns back to you saying, hi, how are you? I'm good. And the kernel is almost described as the order that you execute those trillion operations. So there's a faster way to do it, there's a slower way to do it, and there's an impossibly slow way to do it. Having these kernels for a variety of different hardware platforms enables you to use those new hardware platforms. This is a big part of what gave NVIDIA, people call it the CUDA moat.
Yeah, for sure.
For decades, they had been developing their CUDA kernels.
Yeah.
They made them available to everybody, so nobody had to worry about that. For new chips, they have just a huge gap in those kernels.
No, okay.
But nowadays with AI, closing that gap has been easier and faster than ever.
So, I mean, we can certainly get into CUDA and comparing that moat to this current moment, but what are the economics of this? Like, what's the math on this? What is the waste versus the opportunity of, running this in a more optimized way, getting the best from that GPU kernel, as you say?
Yeah.
What sort of money is being left on the table? Break that down.
Oh, so when we talk about performance engineering in terms of, CUDA kernel optimization or other types of optimizations, like, for example, if you were at like Facebook or Google and you got a 2 or 3% utilization improvement, they would celebrate you up and down the halls. Because that 2 or 3% on a cluster of 100,000 GPUs, we're talking about thousands of, unlocked GPUs essentially, which can result in literally tens of millions of dollars in saving just from reordering software a little bit. So especially for large-scale workloads, AI models generate tokens, and the number of tokens you can generate per second directly drives your bottom line, your margin, in terms of how much money you can actually make on your AI product or service. So improving that even by small percentages, we aim for bigger percentages, obviously, but it's really consequential. And that's why people spend so much time and effort on performance engineering.
Wow. I saw a video last week I was at Dell Tech World of somebody basically asking an AI model to find a paper chip, right? Like a paper clip. And they spent like the best paperclip possible, and it spent like $100 on tokens on, I think it might have been Claude or one of those, to get the best result, right? On a paperclip that costs like what, like I don't know, a couple of cents, right? So the tokenomics conversation right now is feeling like somewhat insane, right? It's almost like a mania that's happening out there. Like we hear about token leaderboards, you know, the more you use, the smarter and more determined you are. So, I mean, what are your thoughts? And like, what does it mean for your company? Because there also seems to be this element to this conversation, especially as an enterprise buyer or any typical buyer in this stack, that you kind of don't know what you don't know as well, right?
So I think especially when Claude Code and Codex have, like, I feel like they have their major unlock moments every now and then. And I do think that the beginning of this year, probably January, February timeframe, a whole new set of applications became, you know, reasonably possible with Claude Code. That's when we saw, you know, from Uber to Amazon, people talking about token leaderboards, token maxing.
Yeah.
Right. And then people quickly realized that, you know, that's not exactly the best metric. I mean, I could, you know, spend 1 million tokens doing paperclip experiments. Right. But ultimately, you know, people want to get to results, and like how many tokens or how many dollars does it take to get to that result? If you can increase your efficiency of the GPUs, we can really start cutting into those costs. And especially with really powerful open source models now, and delivered on platforms like ours, you can get really competitive performance, really competitive intelligence for as much as 10, 20, 30 times less than using these proprietary models.
Wow.
So there's now just a lot more options, especially when the performance engineering, you know, starts to extend beyond just writing kernels and into serving entire models.
So give me the profile of a typical buyer here. Who are you guys targeting predominantly? Like where is the low-hanging fruit in the space right now?
So we have 2 products. One of them launched as recently as last week. But previously, before that, we had built a product called MakoraGenerate. This was a tool that could help you write these GPU kernels for a variety of hardware platforms. And our customers were chip companies. We'd worked with AMD. Okay. We've worked with Google. We've worked with Tenstorrent. And we you know, develop kernels for those chips, and those were really nice and fruitful. But ultimately, we wanted to get into like higher up the stack. Instead of just writing the kernel, can we serve an entire model? So the product we launched last week is our Inference platform, where we serve full open source models, and you can just pay per token. And for this, we're really targeting people who need the fast tokens. A really good example, Claude Opus 4.6, really powerful, really good model. They also have Claude Opus 4.6 Fast. Same exact model, 2 times the speed, 6 times the price. There were people willing to pay 6 times for premium tokens, faster tokens. And so we're building an inference platform that gives people the option for those premium fast tokens across a wider variety of models.
Wow. So you mentioned CUDA, and I know you mentioned AMD, so I presume you use more as ROCm, but you're not really competing there, though, right? You're competing at a layer on that, right? It's a layer above, truly, right? Yeah. And CUDA won, like, they won in a number of ways, but they really won at the API level. Like, that's where, you know, the kind of hearts and minds got taken, right? So in this new era we're in now, where it is about inference, and it is about speed, and about, you know, completely changing landscape of what the API gatekeeper, where it looks like 5 years from now. What do you predict, and like how do you think about that from a competitive perspective? Right. Like who keeps you up at night?
Well, so it's a good point. I think if you asked me this question a year ago, I would have given you a completely different answer.
Okay.
But today, people don't care where their tokens come from. People don't care if it's running on like AMD or NVIDIA or this or that. They just want the tokens to show up, and they want the tokens to show up fast. So in that sense, there's a ton of like really talented inference provider companies out there that have really incredible performance engineering teams. And it's almost just to the benefit of everybody that there's this competition. We all push each other to deliver faster models at a better price. And ultimately, as the performance improves, the margins actually get better on our side too. So we can, you know, rent GPUs, turn a profit margin on top of that while giving users a better experience. And when there's other inference providers like Base 10, like Together, like Fireworks, really pushing the limits of performance engineering, I think it just ends up being a better situation for the consumer, while, you know, we all stay in a nice trench fight trying to get the best performance possible out of the GPUs that we all have access to.
Well, because you mentioned Fireworks and you mentioned a trench fight, there is also this suggestion that some folks will be acquired out of that trench fight, right? And there's some rumors right now, for example, around Fireworks. What is your thoughts on the kind of acquisition convergence? Do you think that's going to become an even harder traveled path over the next year?
I think acquisition is going to be increasingly common, especially in this space, because what they realize is your market cap, your revenue is limited entirely by the number of GPUs that you have access to. And so these companies have two ways to get GPUs. Number one, raise the $1 billion round. Get money out there and rent as many of these GPUs as possible. Number two, get in with a strategic. Get in with the AWS, with a Facebook, with an XAI, somebody who already has 500,000 of these GPUs racked and stacked, and then that becomes your pool of available GPUs. And like I was talking about the supply-constrained world in the beginning, nowadays having money is not enough to get the GPUs that you want. So you need some sort of strategic angle. And I think that's why some of these inference providers are going to be looking to finding that larger, big brother who has all the GPUs already. And they're going to use that to, turn up the revenue hose.
Well, when you're sitting at the New York Stock Exchange and you're learning that we can actually buy our way out of a problem, we know that things are getting really interesting. So Waleed, thank you so much for joining us on theCUBE.
Gemma, thank you for having me.
I'm Gemma Allen, coming to you from the CUBE studio here at the NYSE. This is AI Factories, part of our program with NYSE Wired. Thanks for watching.